Happy 2022. Oh, I should have played Taylor Swift's 22 song today. Oh my gosh, why didn't I think of that till now? Okay, so I can do it with my geometry kids. We took the chapter 4 test kind of before break, did that ball bounce project. So it's kind of been a while since we've done a lesson. We are going to do just a tiny bit of chapter 5 this week. 2 lessons, 2 sections, I should say. So we're starting in 5.1. I don't have like a chapter outline for this chapter because, like I said, we're going to more tackle chapter 5 after the semester exam. We'll talk about all that later. But for now, what students are trying to do are these warm-up problems to see if they remember kind of like the exponent rules that you've done before in Algebra 1. It says evaluate the expression, write your answer using exponents and as a simplified fraction, no decimals. Okay. Need a little more time. I think once I show you a couple of these, it might jog your memory a little bit. How about I give you about 1 more minute to try some? It's okay if this is unfamiliar. I could blame COVID. Thirty more seconds. Okay. So number 1 here says we have 3 to the negative second power raised to the third power. Any ideas of our little like exponent property of how we can like simplify that? Any guesses? Multiply them. Good. When I have a power to a power, I multiply the power. So this is the same as 3. Negative 2 times 3 is negative 6. This is the same as 3 to the negative 6. Now, if you got that far, that's good. Technically, this is not fully simplified. Anybody know why? We can't have negative exponents. Good. Okay? We're going to talk through this. There's like a whole chart with all these rules. We can't have negative exponents. So this is the same as 1 over 3 to the positive 6th. Okay, and you can do this on your calculator. Do 3 to the power of negative 6. And you'll get the answer 1 over 729 because 3 to the power of 6 is 729. Okay, obviously your calculator is probably going to give you a decimal and change it to change it to a fraction. Okay. So if you got this far, that's good. That's kind of one property, power to a power. This is another property, negative power. It says you can like put it in the denominator and it becomes positive. We'll talk about that. Anybody recognize number 2? If I have this like base of 8, a common base and a numerator denominator of 8 to the negative 4 divided by 8 to the negative 6. Do you remember kind of like our rule for what we do with the powers in this case? Subtract them. Good. If you remember that. So negative 4 minus negative 6 ends up being positive 2. So technically that's the same as 8 squared, which is 64. So there it's written as an exponent. This is like the simplified version, 8 squared, which is 64. Okay. You're 2 for 2. Nice work. What about something like number 3? If I have this base of negative 2, this one's being cubed, this one's being raised to the power 6, and I'm timesing them together. Now think of what we did here. When we divided, we subtracted the exponents. So when we multiply, what do you think we do with the exponents? Add them. Yep, this is the same. Now you don't change the negative 2. The base stays the same. You just add the exponents. So that's the same as negative 2 to the 9th. Oops. Now careful here. When you type this in your calculator, you do have to use parentheses because this is saying you want to take negative 2 times itself 9 times. So I should get a negative answer because I'm doing it an odd number of times. It's negative 512. Anybody 3 for 3? That's okay. Let's try number 4. Pretty similar to number 1. Okay, don't let all these parentheses confuse you. This is just saying, hey, -4 is your base, and it's being cubed, and then we're going to raise that entire value to the power of 2. Okay, so it's similar to this, where I have a power to a power, but the reason why I have this extra set of parentheses is because I have a negative base. So this would be the same as -4 to the 3 times 2 to the 6th, which that is 4,096. Why did I get a positive value there? Kayla, do you want to sit here? Do you think it'd be easier? Okay. Why did I get a positive value? It's an even exponent. I times the -4 an even amount of times, so it's going to come out positive, right? Okay. Ooh. Number 5. I can't, if you're thinking it's similar to 2, it's not, because I have 2 different bases here, right? This has a base of 5, this has a base of 2, so I can't subtract their powers. I know there's not a power written on the 5, so what do we just assume the power is? 1, right? That's really 5 to the first. Now, I can't do 5 to the 1 minus -3 because they're not the same basis. So the only thing I could do here to simplify this instead of a negative exponent is bring it to the numerator, and it becomes positive. So that's that answer, which that's 5 times 2 cubed is 8, so we get 40. Now you can type these in your calculator, it'll tell you 40. Well, a lot of times you're going to need to write your answer using exponents, especially on your assignment for tonight. So that's what they would mean by that.
Did you just add 7 and 5?
No, I did 5 to the power of 1 is 5, times 2 to the power of 3 is 8. 5 times 8 is 40. I just moved the 2 up there. You can't add them because they're not the same base. Ooh, this is a good problem. What is anything to the power of 0?
That's 1.
-1.
It's 1, but this is -1. Brayden, do you know why? Can you explain why it's -1? Did you type in your calculator? That tells you -1?
Yeah.
Wow, your calculator's so smart.
I know, right?
It's right.
I like computers.
Okay, let me show you this. This is cool. This is different than this. This problem says, what's -100 to the power of 0? That's 1. Anything to the power of 0 is 1.
Oh, it's because the negative comes after you square it.
Exactly. Order of operations. This has no parentheses, so your base here is 100. Order of operations. What's 100 to the power of 0? 1 times -1. It's -1. See that? So parentheses matter. This is showing you, hey, -100 is your base. Anything power 0 is 1. This is 100 to the power 0 times -1. Okay. Now, if you felt a little lost, it's okay. I'm going to basically kind of reteach you all these rules because it seems like we're a little rusty. But if it feels a little familiar, that's good. But like I said, usually you do this like chapter 7, chapter 8 in Algebra 1. So that would be the COVID year for my dear friends, you. So here's a chart of all the exponent properties. Okay, we're going to go through them one by one, and then I put a little example of each in both. One with numbers, one with variables, because we're going to do both. First property. You don't really have to know what they're called. I'm never going to be like, now what property did you just use? Can you write it down? You don't have to know like their names. You just have to recognize it in math form and know what to do. So what the X is saying is, hey, you have 2 numbers, I'll say, that have the same base, such as 3 and 3. If you're multiplying them together, you add the powers together. Now, when I taught Algebra 1, I went through and showed everybody why these properties work. Okay, with numbers, because 3 squared is 3 times 3, and 3 to the 4th is 3 times 3 times 3 times 3. So what you're really doing is 3 times 6 times, right? We're not going to worry about that now. That's kind of more of an Algebra 1 thing. You just have to recognize these. So that's what I do when I have a product, is I add the powers. Yes?
So are these numbers that have the same base number?
Yes, exactly. Such as this, Kayla, such as like 3s or even variables. You can do that. Now on that one, so that's what I was saying, like here, like on this one, we couldn't do, 10 to the power of 4 because there's 2 different bases. So you can't do that exponent property, only when they have the same base. All right, now with multiplication, we add. So with division, what do you think we do? Subtract, exactly. There's a couple examples. All right, the negative exponent rule. This one's an important one. The negative exponent rule. Because technically, it's not simplified. It's kind of like having a radical in the denominator. Technically, it's just like one of those weird math things. It's not simplified. So if I have a negative exponent, what I do, right now this is technically like in the numerator, okay, because you can write any number as like over 1. So to make it a positive exponent, I put that whole term in the denominator and it would become positive. Okay, such as this. If you have 3 to the negative 5th, that's the same as 1 over 3 to the positive 5th. Similarly, you can draw a little line here if you want. Similarly, if you have a negative exponent in the denominator, you can make that one positive by bringing it up to the numerator, and it becomes positive. When I teach this in Algebra 1, I always say, negative people are sad. So if you have a negative exponent upstairs, he wants to go downstairs, and he becomes happy. If he's downstairs and he's unhappy, he wants to go upstairs, and he's happy, and he's positive. Isn't that fun?
Yeah.
Okay. Power of a power. Most of you guys recognize this one. I have a power to a power. What operation do I do with the exponents? Multiply. Yep. A times B in this case. Here's a couple examples. Okay. Easy example here. If I have 3 cubed, 3 times 3 times 3, and I square that, I got to do 3 times 3 times 3 twice. 3 times 3 times 3. I have a total of 6 factors of 3. Okay. Okay. These two kind of go hand in hand. And this is important. If you have a product and quotient that are raised to a power, you can do this step. If you have a sum or a difference, you cannot. Okay, I'll show you some non-examples later on. For now, I just want to stick with examples so you don't confuse you. So what I mean by a product is something like this, like x times y, or 2 times k. What I mean by a quotient is something like this, x divided by y, a divided by b. If you have a product and a quotient and they're being raised to a power, every factor gets that power. Okay, so in this case, x is a factor, it gets the power. Y is a factor, it gets that power. Don't think of it as you're distributing the exponent because you're not. It's different than a distributive property, okay? It's technically, hey, I have a product, every factor gets that power. Same with quotient. So if I have something as simple as x over y, both, I don't want to call them factors, but both terms get that power. Everything in the numerator, everything in the denominator. So if you have something that has like 10 factors, negative 10a times b squared times c times d, every single factor in that product, if that was being raised to a power, would get that power. Same with the quotient. Okay, one other kind of cool, and I want to call it like a trick. Oh, also like these are obviously still like being multiplied together because you write them side by side, okay? I don't want to call it a trick, but if you have something like this, what you could do, now you don't have to write this down, but this is technically this. Like they both get that power, and then you're like, ooh, I have negative exponents, let's move the x downstairs, let's move the y upstairs. Or what you could do is just flip everything and make the exponent positive, and then apply the power to both the top and the bottom, and you agree you would get the same answer as if like we were to do it like that first way of applying the power first and then fixing the negative exponents. So if you see something like that, if you have a fraction raised to a negative exponent, you can just flip it right away and make the exponent positive and then go from there. Sometimes it's easier to do that. Sometimes it's not. It just depends on the problem. All right, last property. This is my favorite one. Anything to the power of 0 is 1, not 0, 1. Anything to the power of 0 is 1. Okay. So tonight, you have a Khan Academy assignment that's just like practice over like Algebra 1 skills. All right, so I'm going to walk you through like just some basic exponent property ones, and I screenshotted Khan Academy, so they're similar to like your homework ones. And then we'll kind of tackle like Algebra 2 types of columns, because obviously in Algebra 2, we're going to step it up a notch. They're not going to be like all these like basic ones like this. But for tonight, your Khan Academy homework is pretty basic. It's just like a review over the Algebra 1. I like took this from the Algebra 1 curriculum in Khan Academy. I'll show you the Google Classroom on homework in a second here, but let's just try some of these. So it says, simplify. Now read the directions carefully. Rewrite the expression in the form of having a 5 to some power n. All right, so I see this. I have the same base, 5 to the power of -8 times 5 to the -10. What operation, folks, since I'm multiplying those with the two same bases, what operation would I do with the powers? Add them. Yep, add. You need to shout out. Add them. Okay. That gives me 5 to the -18th, because -8 plus -10 is -18. Now, normally, we don't leave our answer like this, because I just told you we can't have negative exponents. But look at what Khan Academy wants you to do. They want you... I don't know where that just went. They want you to leave it in that form. So pay attention to direction. So my answer here would just be 5 to the -18. That's what they're going to want you to do on Khan. Now, in the future, because I don't want to teach you like the wrong thing, in the future, what you should do to simplify this and make it a better answer is to get rid of the negative exponents by putting that in the denominator. So this is technically like the best answer. So just pay attention to your directions in Khan, okay? Because like I said, they're going to be pretty basic examples for your homework tonight. That's the Khan Academy answer. This is what I'm going to want you to do. Take it one step further. Okay. Let's try another one. Let's throw some variables in. I actually think exponent properties are easier to do with variables. So here I have a to the -2nd times 8 to the 7th, and I'm going to square that. Now, there's a lot going on here. You're like, oh, I see a negative exponent, and this whole thing's being squared. Sometimes I like take care of the negative exponents kind of like last. So me, when I see this, the first thing I see is, hey, I have a product here. I have a to the -2nd times 8 to the 7th. And what they're doing with those parentheses, they're showing me that this product is being squared. So what that means is every factor in there, that factor and this factor, need this power of 2. Now, since they already have powers on them, if I have a to the -2nd and I raise that to another power, what operation would I do with those powers? Not add. Power to a power.
Multiply.
Multiply. Yep. If I have a power raised to another power, I would multiply those. All right, so don't forget that a also gets that power of 2. Now, I have times 8 to the power of 7. That factor also needs a power of 2. It already has a power, so a power raised to another power, multiply those. Okay, everybody with me? I used 2 properties there. First, product property, meaning each factor gets that power of 2. Second, power to a power, so I'd multiply those. All right, let's do that math. That's obviously a to the -4 times 8 to the 14th. Now, looking at my options here, I see C, hey, is the exact same thing I have. So again, that's how Khan's going to have you leave this. The better way to simplify this is to move that negative exponent downstairs. Becomes happy, and then that 8 to the 14th, that's a positive exponent. That would stay upstairs. It's happy. It's good. That's like the best answer. So for Khan, just pay attention to the directions. If it's multiple choice, look for something like that, but in the future, we're going to fully simplify that. All right, everybody good so far?
Mm-hmm.
Is it coming back to you yet? No. Okay.
I don't remember doing this, but like I know some of it. It's weird.
You're like, how do I know this? All right, let's try this one. Which expressions are equivalent to 7 to the negative 2 times 7 to the 6? Choose two answers. All right, well, I have the same base here. So what operation would I do with the powers? Add them. Since I'm multiplying the two bases, I'd add these. So this is the same as 7 to the power of 4. Okay, we don't even really have to figure out what that is. Let's simplify letter A. Ooh, I see division. And I have the same base. So if they have the same base, what operation can I do with those powers? Subtract. I would subtract 2 minus, don't let the negative throw you off. And you guys, you always do bottom minus top. Okay. So 2 minus negative 2, that gives me 7 to the 4th. Another way we could have tackled that problem, you don't have to write this down, but this is negative, move them upstairs, becomes positive, same base, add the powers. All right, that could have been another way to tackle that one. This one I only had to use one property. All right, well, that one's the same. That's 7 to the 4th. Let's try B. Subtract the powers. So 6 minus negative 2 is 8. And that one's not the same. 7 to the negative 12 is 1 over 7 to the positive 12. That's not the same. 7 squared squared, power to a power. What operation do I do with the powers? Multiply. Hey, that's the same as 7 to the 4th. Okay. So tonight, for your homework, I think I have it over here. I assigned you 3 lessons on Khan Academy. 5-1, here we go. There's 3 practice. There's no videos or anything like that. It's not like the scatter plot one. It's just 3 practice. So I linked Khan Academy, and that'll be some of the bookwork you can do. But now we're gonna kind of step it up. This is basically review of our Algebra 1. Okay, exponent property. So that I want you guys to do that by tomorrow. Oh shoot, I just moved it to the wrong topic. I want you guys to do that for tomorrow. So when we get to these meatier ones, you have the exponent properties down. All right, so here's kind of getting a little bit more difficult. So you need to understand basically these rules of a monomial. Are you guys familiar with that vocab term, monomial?
Sounds familiar.
Okay, this is probably also something you do in Algebra 1, but I'll explain what a monomial is. A monomial is basically one term. All right, now in math, a term can have numbers, it can have letters, it can have power. So something like this, you don't have to write this down, but that's a monomial. This is all we'd consider that one term, right? But if I had this, these are 2 separate terms. That's called a binomial. 2 terms, binomial. They're all examples of polynomials. And that's what chapter 5 is we're going to focus on polynomials. So that's what this basically means. Simple monomials. So I'm just going to give you one term. Now, technically here we have a product, but we're going to combine it to one term. Here's basically some rules of when you're fully simplified. There's no powers of powers. So if you see something like this, powers raised to another power, that's technically not simplified. Each base appears exactly once. So here I see I have 2 separate bases of A. All right, so that's not fully simplified. All fractions are in simplest form. So if I have something like 3/6, I need to reduce that to 1/2. And lastly, there's no negative exponents. Okay, so those are basically the rules of kind of when you know you're done. Now, the tricky thing about these problems is sometimes there's different ways to go about them. Sometimes your first step might be oh, hey, I see this negative exponent. I'm going to flip everything right away. Or maybe you do the power of a quotient and apply the power first. And I guess the more you practice it, the easier it is to determine how to start them. But I kind of start them dependent on the problem, how it's set up. So what I mean by that is if I look at number 1 here, see how I have a fraction raised to a negative exponent? So what we could do is give the 2 a negative exponent, give the a squared a negative exponent, the b third a negative exponent, but now I'm going to have a bunch of negative exponents. So me personally, I would use that little exponent property that I showed you of I would flip this fraction or do the reciprocal. And you guys remember what that would do to that power? make it positive. And then you're like, ooh, now we're working with nicer numbers. Sometimes I might not do that right away, but that would probably be my first step here because I'm like, hey, I see a really easy change of flipping that right away, and now I'm working with just positive exponents. The next thing I would do, and it's kind of like the same as order of operations, so please excuse my dear Aunt Sally. Before I multiply these together, I have to apply this power, right? So the next thing I would do is that quotient property where I'm going to give every factor in here, every like little number or letter, that power. So b to the third is going to get the power of 2. Now when I have a power 2 power, I multiply those. So that become b to the 6th. I'm not going to write out my steps. You can if you want to. 2 would get that power. I'll write out that. A squared would get that power. I'd multiply those. So that become a to the 4th. Okay. Now after I evaluate that, I can actually multiply these together. So up top, I have b to the 6th times b to the 1st. What would that become? B to the 7th. We'd add them. Yep, b to the 7th. Good. All right, 2 squared would become 4. When we multiply fractions, guys, we multiply straight across, right? That's why I'm doing this. So then a to the 4th times a to the 1st, I'd get a to the 5th. Okay, so let's kind of go through my checklist here. Do I have any powers of powers?
No.
No. Does each base appear exactly once in my answer?
Yeah.
A, B, only once. All fractions are in simplest form. I have the fraction 1/4 here, because technically there's a 1. 1/4, that's in simplest form. Do I have any negative exponents?
No.
No, so we're done.
Yeah.
That's our answer. I forgot what time this class ends. Jeez, I'm gone for 1 week.
09.
09? Okay, thank you. All right, let's try another one. These are fun. I don't have any powers here, so I'm just going to start by multiplying these. And again, how you multiply fractions, multiply the top, multiply the bottom. I personally, when I multiply like numbers and letters, I like to put the numbers in front. So I would write that product as 2b to the 6th. All over 4a to the 4th b.
Oh, I actually did.
Okay, who can give me one reason why this is not simplified yet? Sydney.
2 b's.
There's 2 b's. Another reason. Kayla?
Fractions aren't simplified.
2/4 is not simplified, right? Okay, I usually do coefficients first, just because my brain works left to right. So that simplifies to 1/2. You don't need to write the 1 in front. There are 2 b's. So Sydney, what would I do with these powers 6 and 1? If they're being divided. Nope, that's power to a power. Subtract. Is that what you're going to say?
That was what someone said.
6 minus 1 is positive 5. And then a is by itself. So you would just leave it. We don't have any negative exponents. That'd be my final answer.
Question.
Yes.
So, it wouldn't. Could you, for some reason, I thought this all this you'd flip the 2b and make it negative b over negative 2, but that wouldn't work with it because it'd be negative 8, a to the 4th, right? Like, why couldn't you do that?
You wanted to flip this?
Yeah.
Why?
I don't know. It just seems
If
like
it was-
something I could do.
If it was dividing, you times by reciprocal. Is that what you're thinking of?
Yeah, I don't know.
Or like these don't have any negative exponents. So you just literally just multiply them together. You multiply the tops, multiply the bottoms.
Yeah, that makes sense. All right.
Okay, let's try another one. We only have a few more to do. We might finish a little early. We'll see. I shouldn't. Oh my gosh. Holy 7s and 5s. Again, order of operation. I see this is all being raised to this exponent. So I'd have to do that first before I do any multiplying or dividing. Let me ask you this question though. If I start within the parentheses, can I add these powers together and do 35 to the first? No. They're not the same base. That's a base of 7, this is a base of 5, so you can't combine them. Okay? That's why we have this product rule. You have a product where you can't combine them any further. Each factor gets that exponent. So 7 cubed to the power of negative 2 would be 7 to the negative 6. You'd multiply those. 5 to the negative second times negative 2 would be 5 to the positive fourth. So this time I didn't like flip my fraction right away. You could have. You can do it that way if you want to, but here's where I'm at. Okay, all I did was I did that power. Everybody good with that?
Mhm.
Okay, the next thing I would probably do is subtract the exponents. So I have 7 to the negative 2 minus negative 6. Now I do want to write this out because sometimes it can be confusing when you're subtracting negative exponents. And here I have 5 to the 1 minus 4. And again, you always have to do top minus bottom. Just like the order of division matters, the order that you subtract the exponent matters. Now watch what happens here. Nice. My exponents kind of just work themselves out with the 7, right? Negative 2 minus negative 6, that'd be plus 6. I get 7 to the positive 4. And you're like, okay, so I don't really have to do any flipping. The negative exponents kind of work themselves out. But then with the 5s, 1 minus 3, you're like, oh, well, now I have a negative exponent on the 5. And sometimes that happens. So sometimes I tell students that the negative exponents confuse you. Just save it till your last step. Because you can do these problems without flipping anything. But once you get to the last step, can't have negative exponents. That 5 has to go downstairs. Becomes happy. That would be my final answer. Now you might see the answer written like this. I gotta check like how your textbook writes these, but 7 to the power of 4 is 2,401, and 5 cubed is 125. So that's obviously the same thing, just like evaluating those powers. Do you guys know how to do bigger powers than 2 in your calculator?
Yeah, I use
Okay, Jim said no. You just use this button.
the carrot. The carrot.
So if you want to do 5, you do 7 to the power of 4.
Carrot. I couldn't.
Let me just show you something really quick. You don't even have to write this down. Just look up here. Did anybody like have the idea to like move this upstairs and make this a positive exponent? Just curious. No? Okay. You could do it that way too if you wanted to. But just know if you do that, the only thing that becomes a positive 2 is that one because you're technically like moving this whole thing. But if nobody thought that way, let's just not confuse anyone. Okay. 2 more for today. And then we can go over the 3 common mistakes. Yeah. All right, now this one on number 4. So I have this fraction raised to the negative second power. And then I have this guy right here. So again, couple ways we could do this. But personally, when I see something like this, I'd flip it right away and make it a positive 2. Because then you're like, ooh, nice, I can work with some positive exponents. So you could flip this, become y squared, so you just do the reciprocal, and that would become a positive 2. That's a nice, easy trick when you see something like that. All right, now I'm going to have to apply that power before I can tackle multiplying in that 12x to the 4th times y to the negative 10. Now I got to actually apply that power to my whole fraction. So upstairs in my numerator, y squared, if I square that, I multiply those, that'd be y to the 4th. Here's a common mistake. When you have a number, people forget that you have to square that as well. So you do have to square the 6. And you do have to square the x. Now that x really just has a 1, so that's obviously just going to become x squared. Okay. So here you can think of this as like over 1, or if you wanted to, you could move the y downstairs if you wanted to, but this is probably how I would do it, is I would then multiply straight across. Okay. So in my numerator, the first thing I would do is I have 12 times 1, technically, so I'd write the 12 first, and I like to do things in alphabetical order. So then I'd probably tackle the x's next. I'm like, okay, I have that x to the 4th. And then I do see I have a couple y's that are being multiplied together. So what operation would I do with their powers? Add. 4 plus negative 10 is negative 6. Okay, everybody go with that? Downstairs, I have 36 times 1 And I just have x squared. This time there's 3 reasons. We're not done. There are 3 reasons why this is not simplified. Somebody give me one of the 3 reasons I'm thinking of. Brayden.
The X is in the numerator and denominator.
I have 2 x's. Good. We need to fix that. What's another thing I need to fix?
Negative.
Negative exponent. Good. Last one.
You can reduce it.
We can reduce 12/36, right? All right. So I would probably reduce the fraction first. I like to do that. So that's 1/3. Again, you don't need to write the 1. The x's, I would subtract the powers. So 4 minus 2 is 2. And then the y to the 6, I got to move that guy downstairs. And then we're good. Any questions? This next one looks scarier than it is. All we really have to do in this one, it's already one fraction. All we have to do is basically combine all the x's, y's, z's, and then reduce this fraction 2/4. So let's start with the fraction. 2/4 reduces to 1/2. So again, you don't need to write the 1. Now, x to the -8 minus -2 would become -6. Y to the 5 minus 5 is y to the 0. Z to the -7 minus -8 becomes z to the positive first. Okay, everybody okay with what I did there? I reused one property really. Powers of a quotient. Or maybe it's quotient of powers. I don't know exactly the wording. Quotient of powers. Quotient of powers, that's the one. Quotient of powers. Okay, let's simplify this a little bit. So I already reduced my fraction so that 2 stays downstairs. X to the -6 that needs to go downstairs, become happy. Y to the 0 is what? 1. And then z to the first is just z. That one stays upstairs because it's a positive power. Now, another way you could think of this, guys, is those y to the 5s, since you technically have 5 at the top, 5 at the bottom, they kind of like cancel each other out. So if you think about it, if I have y to the 5th over y to the 5th, that's obviously just 1. Anything over itself is just 1, right? But all these like factors like cancel each other out. But careful, you're not left with 0. It's technically 1. All right, I'm going to show you the 3 common mistakes that people make with these. And you're not going to be that person, right? All right, so this one, I'm not going to lie. When I was in college, one of my jobs was I tutored people in math. I got paid for it. It was awesome. I got to do math and I got paid. It was great. It's like my real job. And college students would do this all the time. This one right here, like college level students. So you can be smarter than a college student if you don't do this. If you have a sum that's being raised to a power, that is not the same. Oh, let me just give that power to each term. That only works with products and quotients. If you do this, I'm going to give you a little. Just kidding. What you would do, so let me just throw in some numbers here. Like if you had something like this, x plus 3 squared. We know that's not the same as x squared plus 9. Maybe you've done this before by accident. We know this is x plus 3 times itself twice, and we'd have to distribute it out. Okay, that's how we would tackle that problem. We're going to do more like that tomorrow. You can't like distribute exponents to a sum. Okay, if you were to multiply this out in your head quick, you get x squared plus 6x plus 9. Okay, that's not the same as x squared plus 9. There's one common mistake. Second common mistake, and again, you'll notice that these are all like sum. If you have something like this, you cannot do this. You cannot just, hey, I'm going to move the y down like that. That's not the same. I'll show you what you should do. What you should or could do is split this up into two fractions. Like, okay, you have x squared that's being divided by 5. And you have y to the negative second that's being divided by 5. And now, since they're each like a single term, like a monomial, now you can apply that property of move the y downstairs. You'd just be left with a 1 up there. Okay. I think we'll stop there. I'll show you the third one tomorrow. The bell's just gonna ring here. So again, guys, I want you to know you do have homework that's due tomorrow. Khan Academy, and you're gonna hand in your work. So I put that on Google Classroom. Keep your work organized on another piece of paper. You're gonna turn it in tomorrow. It's pretty quick and easy. There's only 3 practice sections, and it's all like those easy ones we were trying. It's all just like basic exponent property ones. There's not really any with those like difficult ones. So no, you the y is put down.
Yeah.